All right, starting here in number 16, actually, unfortunately, there's a typo on the screen here, but it's been fixed on your version. I just didn't want to have to recreate this slide to do this. We're going to say that angle A is 60 degrees. So that means A down here is 60, which if this is 90, which it is, then that means that angle C is 30 degrees. So we would just drag that up there. And then we're given that this is 3, given to us here. So then the basic rules of a 30, 60, 90 right triangle, whatever is across from the 30, you double that to get the hypotenuse. And the reason for that, again, so I'll double that and get this here. The reason for that is, you can always think about a 30, 60, 90 triangle as literally half of an equilateral triangle. You know, if I had the entire angle here at the top, that would be 60. 2/30 would be 60. And so this is half of the side. So the whole side should be 6. Half of it is 3. And then once I have two sides, I can always do Pythagorean theorem to find this last side, which is 3√3. So this is 3√3. Now that whole doubling the triangle to create an equilateral triangle, a 30, 60, 90 triangle being half of an equilateral triangle, that's just if you don't remember. That's where it comes from. That's what to do if you get stuck and you like have a total mental freeze and you just can't remember. But this is something that you should know. You should know your special right triangles for calculus. Number 17, very similar problem. In this case, we're given that angle D is pi over 4, and that segment F is 8. Well, if D is pi over 4 and angle F is 90 degrees or pi over 2, well, that just leaves another pi over 4 for over here. It's the only option. And so once again, if you just remember your special right triangles, then you know that in a 45, 90 triangle, the rule is that the hypotenuse is x√2, and the other sides are x. So you can just write that equation, that 8 equals x√2, and you can solve that. You can also just kind of figure it out and solve, but just to show a little bit of the work there, 8 over √2 is equal to x. Multiply numerator and denominator by √2 to get that radical out of the bottom. 8√2 over 2 gives me 4√2 for x, which is the side length here and here. And the friendlier way, of course, to do this problem is if I had given you the leg, the shorter side, and said, okay, well, if this is 5, then the hypotenuse is 5√2. But we can figure it out this way as well. Just like in the 30, 60, 90, for the 45, 45, 90 triangle, you can always, if you really get stuck, you can always say, okay, well, this is x, and then you have basically a right triangle where you've got x, and 8. And because it's a right triangle, you know that x squared plus x squared equals 8 squared, just Pythagorean theorem, and you can solve that. You can always come back and work out the definition of the special right triangles. Obviously, better if you know them, have them memorized, but sometimes you got to come back and figure out, wait, what was that again? What was that rule? I forgot. Okay. The next couple of problems are about linear equations. Now, a lot of what we do in the first semester of calculus is about linear equations. It's kind of shocking sometimes, like, wait, we're just writing equations of a whole bunch of lines here. And yes, that is what we will be doing. There's some stuff about calculus that we will learn that will allow us to write the equation of the lines we need to write, but lines is a big part of calculus. So they want us to write the equation of or write an equation of a line that contains these 2 points. The way that I've set this up, I know it looks a little crazy because it's like there's hardly anything in here and then just all these boxes, but it's y minus something equals something times parentheses x minus something. This is point-slope form. The reason that I've given you this in point-slope form, some of us don't like point-slope form, but in calculus, point-slope form is definitely our friend. It makes it so much easier. So I want you to get used to point-slope form here. So with point-slope form, I need to know a point and a slope. You can pick either point, either this one or this one. And the general version of point-slope form, y minus y1 minus equals m times x minus x1. So you can pick either point for your y1 and x1, just make sure it's from the same point. So I'm going to make this y minus negative 5 is equal to blank, the slope, times x minus 1. Now I need to know the slope, and so I just use the slope formula. Y2, 4 minus negative 5 over 2 minus 1 is 9. That's my slope. And I just as easily could have done this as y minus 4 is equal to 9 times x minus 2. Schoology would accept either answer there. Now we're calling that line L in number 19, and we're saying, okay, given that line L contains those points, hey, that's the points we just worked with, make the equation of a line perpendicular to line L passing through the point 1, negative 5. Well, we're going to deal with the 1, the negative 5 the same way, so this is y minus negative 5 equals the slope times x minus 1. The slope is just the opposite reciprocal. Perpendicular lines have opposite reciprocal slopes. So the opposite, originally we were positive 9, now we're negative. Reciprocal, 1/9. Now parallel, well, parallel lines have the same slope, and line L is the original line that we worked with. That has a slope of 9, so we have a slope of 9. And then we're going through this point, not through the original points, because if you were parallel to that line and you went through those same points, it would be the same line. So we have to have a different point to go through. So that's y minus 6 is equal to 9 times the quantity x minus negative 3. Okay. I think that'll be all for this video.